First step is to count up the valence electrons. So we've got 18 valence electrons, that means 9 electron pairs. Let's first connect up the outside atoms to the center atom. And now we'll connect or complete the octet of the outside atoms. So each of them is going to require 3 electron pairs. And now the octet on the outside atoms is complete. We can look to the center atom. The center atom is electron deficient, but we do have one remaining lone pair to put on the nitrogen. We've run out of electrons, but now nitrogen is electron deficient by one pair. We're going to need one double bond. This is going to result in 2 resonance structures because we can use either oxygen atom as the source of the lone pair. So let's consider this one. We have this lone pair converted to a bonding pair, and we'll rewrite the structure. Now, the conversion we've shown results in a double bond between the nitrogen and the left oxygen atom. And we have 2 lone pairs remaining on that oxygen atom. Our nitrogen still has the lone pair on it, and the right oxygen has 3 lone pairs. If we chose the right-hand oxygen to make the double bond, it will result in this resonance structure. So we have 2 equivalent resonance structures, each of which has a complete octet for each of the atoms. We can see that considering the oxygen atoms. Here we have 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and 2, 4, 6, 8. Now let's look at the nitrogen atoms. So we have 2, 4, 6, 8, 2, 4, 6, 8. So all atoms follow the octet rule. We have the correct number of electrons. This is a set of valid Lewis dot structures.